Imagine a time before time, a space before space. Scientists tell us that the universe began with the Big Bang, an explosive moment of creation that brought everything into existence. But what if that wasn't the beginning at all? What if the Big Bang was just another chapter in a much older, much grander cosmic story? For decades, we've been told that space, time, and matter all emerged from a single point of infinite density, what physicists call a singularity, a moment where the laws of physics themselves broke down and reality as we know it was born. But here's the problem. If time itself began with the Big Bang, then asking what came before should be meaningless, right? And yet many of the greatest minds in physics today believe that our universe didn't simply emerge from nothing. Instead, it may have been shaped by forces and events stretching far beyond what we can currently understand. If that's true, then what came before the Big Bang? And if there was a before, does that mean the universe has always existed? These questions aren't just abstract thought experiments. They challenge the very foundation of modern cosmology. The standard Big Bang model is powerful. It explains why galaxies are rushing away from us, why the universe is filled with cosmic microwave background radiation, a faint afterglow from the early universe, and why elements like hydrogen and helium exist in the precise ratios we observe today. But this model also leaves us with unsettling mysteries. If the universe emerged from a singularity, what caused that singularity? Was it truly a beginning, or just a transition from something even older? Every great journey starts with a few brave explorers. Right now, Cosmic Whispers is just beginning, and your support means everything. If you enjoy unraveling the mysteries of the universe, hit subscribe. It's free and it helps us grow this community together. Now, let's go deeper. The Big Bang model, as elegant as it is, has a serious problem. It relies on the assumption that time and space had a starting point. But in physics, something coming from absolutely nothing is deeply unsatisfying. The idea that a singularity, an infinitely dense, infinitely small point, suddenly expanded into everything we see today is less of an explanation and more of a placeholder for missing knowledge. And when we try to apply the known laws of physics to this supposed beginning, things fall apart. General relativity, which describes the fabric of space and time, works beautifully at large scales. It tells us how planets orbit stars, how black holes bend light, and how the universe expands. But when we rewind the clock back to the Big Bang, something strange happens. Our equations break down. General relativity predicts an impossible state of infinite density, infinite temperature, and zero volume. A clear sign that we're missing a crucial piece of the puzzle. This is where quantum mechanics comes in, the set of rules that govern the smallest scales of reality. But there's a problem. Quantum mechanics and general relativity don't agree on what happened at the beginning of time. They describe two completely different universes, and at the moment of the Big Bang, they clash in ways we still don't fully understand. This tells us something critical. The Big Bang wasn't a beginning in the way we often think of it. Instead, it was likely a transition, a moment in a much older, much stranger cosmic process. But if that's true, what existed before? One radical idea comes from the concept of a cyclic universe. What if the cosmos has been expanding and contracting in an eternal cycle? Instead of a single one-time event, what if our universe has been reborn over and over again through endless cycles of Big Bangs and Big Crunches? Theorists like Paul Steinhardt and Neil Turok propose that the universe doesn't just expand forever. It eventually slows down, collapses under its own gravity, and then rebounds into another Big Bang. In this model, our universe isn't the first, nor will it be the last. This idea isn't new. Ancient Hindu cosmology described an eternal universe that expands and contracts in infinite cycles, much like a cosmic heartbeat. But modern physics is now giving this idea serious mathematical backing. According to string theory, the universe might be part of a higher dimensional structure, where massive invisible brains, short for membranes, collide. These collisions could trigger a new Big Bang, creating one universe after another, in a never-ending cycle. If this theory is correct, then before our Big Bang there was another universe that lived and died, and before that, another, stretching back infinitely into the past. But not everyone is convinced by the cyclic model. Another competing idea suggests that our universe didn't emerge from a previous one, but from a much larger, eternally inflating space. This brings us to one of the most mind-boggling ideas in modern physics, the multiverse. According to inflationary cosmology, our universe is just one bubble in an ever-expanding sea of other universes. Imagine boiling water. Bubbles constantly form, expand, and pop. Now replace water with a strange form of energy that causes space itself to expand at incredible speeds. In this theory, space is always inflating, but every so often, a tiny patch of it slows down and becomes a universe like ours. If this is true, then our Big Bang wasn't a unique event. It was just one of countless other Big Bangs happening across an endless multiverse. This theory isn't just speculation. There's actual mathematical evidence suggesting that inflation never truly stops. If true, it means that universes are being born all the time, in an endless cosmic foam. And that means before our Big Bang, another universe may have already existed, and another before that, stretching back in an infinite chain of cosmic creation. But this raises a new, even stranger question. Could we detect evidence of a previous universe? Some scientists believe we might already have hints. The cosmic microwave background, the faint afterglow of the Big Bang, contains tiny anomalies that don't quite fit our models. Some physicists, like Roger Penrose, argue that these could be scars from a previous universe, imprinted onto our own like echoes from an earlier cosmic era. So, was the Big Bang truly the beginning? Or was it just a moment in a much grander, eternal process? If the universe has always existed in some form, does that mean time itself is infinite? And if so, could the cycle ever end? We've only just scratched the surface. And the deeper we go, the stranger the answers become. Now let's venture even deeper into the rabbit hole of cosmic mysteries. Imagine for a moment that the universe you know, the one you've seen through the lens of telescopes and feel in the rhythm of the stars, wasn't born from a singular moment of creation. What if instead it was simply one iteration in a never-ending cycle, where each new Big Bang is just a fleeting heartbeat in an eternal cosmic dance? This is the bold assertion of the cyclic universe theory, and it has shaken the very foundations of how we think about the cosmos. At the heart of this theory is the idea that the universe is not a one-time event, but a recurring one, an eternal process that expands and contracts over and over without end. In this view, the Big Bang wasn't a sudden birth, but rather the latest in a series of cosmic rebirths. If true, this would suggest that the universe has always existed in some form, never truly beginning and never truly ending. But what evidence supports such a radically different idea? Let's dig into it. The concept of a cyclic universe isn't entirely new. Ancient cosmologies from cultures around the world, including Hindu and Greek philosophy, proposed similar ideas. Hindu texts describe a universe that is created, destroyed, and reborn in an infinite cycle. Each creation is followed by a long period of destruction, after which a new cosmos is brought into being. But these ideas were largely ignored in modern science, considered mythological or philosophical rather than scientific. Then came the 20th century, and with it the birth of modern cosmology. In the 1920s, the astronomer Edwin Hubble discovered that galaxies were moving away from each other, a revelation that suggested the universe was expanding. This was the key to the Big Bang theory, which proposed that the universe began as a singularity, an infinitely small, infinitely hot point that rapidly expanded into everything we see today. The discovery of cosmic microwave background radiation in the 1960s provided further evidence, revealing the faint afterglow of the Big Bang. But even as these discoveries confirmed the Big Bang model, scientists began to realize that something was still missing. The idea that the universe emerged from absolute nothingness seemed increasingly unsatisfying. How could something come from nothing? What triggered the Big Bang in the first place? And why is the universe so finely tuned to support life? These questions led physicists like Paul Steinhardt and Neil Turok to propose a bold new vision, the cyclic universe model. In the cyclic model, The Big Bang is not a one-time event but part of a much larger ongoing process. The key idea is that the universe undergoes endless cycles of expansion and contraction, with each cycle beginning with a Big Bang and ending in a big crunch, where the universe collapses back in on itself. When the universe reaches a point of maximum contraction, it bounces back in a new Big Bang, starting the cycle anew. This process is continuous, stretching back to infinity and, according to some versions of the theory, continuing on forever. But here's the twist. In the cyclic model, the universe doesn't start from a singularity each time. Instead, it gradually evolves through a process of slow contraction, followed by a dramatic rebound. Think of it like a slingshot. When the universe reaches the maximum density, it releases and begins to expand again. But unlike the traditional Big Bang, where space itself suddenly bursts into existence, the cyclic model proposes that space and time evolve in a more gradual, continuous manner. This theory finds support in certain aspects of string theory, particularly the idea of higher dimensional brains. Imagine our universe as one of many multidimensional brains floating in a higher dimensional space. These brains can collide, and when they do, they can trigger a Big Bang, giving birth to a new universe. Each collision results in a new universe, with its own set of physical laws and properties. If the cyclic model is correct, each Big Bang would be the result of one of these brain collisions, and the universe we live in today is just the latest iteration in an endless cosmic cycle. In a way, this theory turns the Big Bang on its head. Instead of a singular one-time event, the Big Bang is just a moment of transformation, a brief instant in the grand, unending process of cosmic rebirth. But could this be the whole story? Could there be more to the universe's origin than even this? Some scientists believe the answer lies in a more radical theory, one that extends the cyclic universe concept even further. This theory posits that our universe is just one of many in a vast multiverse, a never-ending collection of separate, yet interconnected universes. According to this view, the Big Bang that created our universe was not the first, and it won't be the last. Instead, our universe was born from a quantum fluctuation in a larger, constantly inflating space. The idea of a multiverse, multiple universes, each with its own set of laws and physical constants, might sound like science fiction, but it's grounded in some very real physics. The theory of cosmic inflation, which suggests that space expanded at an incredible rate just after the Big Bang, predicts that inflation never truly ends. It keeps going, giving rise to new pockets of space that become independent universes. These new universes may have different laws of physics, different constants, and potentially even different dimensions of space and time. Our universe, in this model, is just one bubble in an eternal sea of cosmic foam. If the multiverse theory is correct, then before our Big Bang, there may have been countless other Big Bangs in other universes. Some may have been similar to ours, while others may have been radically different. And the most mind-boggling part, the idea that the multiverse is eternally inflating, means that there could be an infinite number of universes, each constantly coming into being. The Big Bang in this case is not a unique event. It's just another moment in an ongoing process of cosmic creation. But where does that leave us? If our universe is part of a multiverse, can we ever detect evidence of other universes? It's a tantalizing question, and one that some scientists believe may have an answer. Some researchers are looking for signs of brain collisions, where our universe might have collided with another brain in the distant past, leaving traces in the cosmic microwave background radiation. Others think that we might find evidence of other universes in the laws of physics themselves. If the constants in our universe are finely tuned in ways that suggest an intelligent hand at work, could this be a sign that other universes have set the stage for our own? The more we look, the more questions arise. If the Big Bang wasn't the beginning, what does that mean for our understanding of time itself? Could time, like the universe, be part of an eternal cycle, stretching infinitely in both directions? The deeper we go, the stranger the answers become. And the more we realize that our understanding of the universe is just a small part of a much larger, much more mysterious whole. But one thing is clear: the story of the cosmos is far from over, and there are still many chapters left to uncover. If the Big Bang wasn't the absolute beginning, then what does that mean for time itself? We think of time as flowing like a river, always moving forward, never stopping. But what if time, like the universe, is cyclical? What if the past, present, and future are just points on an endless loop? This idea challenges everything we think we know about existence. It suggests that our universe, our very reality, is not a single story with a beginning and an end, but a recurring narrative, written and rewritten across eternity. One of the most intriguing ideas that emerges from this perspective is known as conformal cyclic cosmology, proposed by the legendary physicist Roger Penrose. He argues that what we call the end of our universe, a cold, dark, empty expanse after all the stars have died, is actually indistinguishable from the conditions that existed before the Big Bang. In other words, the ultimate fate of one universe may naturally give birth to another, but how could this be possible? To understand this, we need to consider the strange and unexpected ways in which physics behaves at the extremes. Right now, we live in an expanding universe. Galaxies are drifting apart, and over trillions of years, they will continue to separate, until they are unimaginably distant. Eventually, all stars will burn out, black holes will evaporate, and matter itself may decay. What remains is a universe with no structure, no complexity, and no information. Just a vast emptiness filled with radiation and particles spread infinitely apart. This state is known as the heat death of the universe, and for decades it was considered the inescapable final chapter of cosmic history. But Penrose saw something remarkable in this bleak future. He realized that when the universe is completely empty, space and time lose their meaning in a way that is surprisingly similar to the conditions before the Big Bang. In both cases, the universe lacks any fundamental scale. There is no way to measure distance, size, or even the passage of time itself. Penrose proposes that in this extreme state, the universe naturally resets, transitioning smoothly from a dying cosmos into a new, reborn one. In this view, the Big Bang wasn't the birth of space and time. It was just a transformation, the moment when one eon ended and another began. If this theory is correct, then the universe is eternal, continuously cycling from one phase to the next. But could we ever prove such an idea? Incredibly, some physicists believe we might already have evidence. Penrose and his colleagues have analyzed the cosmic microwave background, the faint radiation left over from the Big Bang, and claim to have found mysterious circular patterns that shouldn't exist under the standard model of cosmology. These circles, they argue, could be scars left behind by supermassive black holes from a previous universe, providing a glimpse into the remnants of an earlier cosmic cycle. But not everyone is convinced. The problem with looking for evidence of a previous universe is that the Big Bang, by definition, wipes out most of the information from whatever came before it. It's like trying to reconstruct a book that was burned to ashes. You might find scattered clues, but the original story is lost. Even if the universe does go through endless cycles, the laws of physics may erase all memory of the past with each rebirth. If that's true, then we might never be able to prove beyond doubt that another universe came before ours. Yet, some physicists believe there's another way. If the universe has undergone cycles before, then maybe it isn't just space and time that persist through each iteration. Maybe the fundamental laws of physics themselves evolve across cosmic cycles. This idea is known as cosmological natural selection, and it suggests that just as biological evolution favors organisms that survive and reproduce, the universe itself may be shaped by a process of selection across multiple Big Bangs. Universes that form in ways that allow black holes to exist could be more likely to generate new universes, since black holes might be connected to the creation of new cosmic regions through processes we don't yet fully understand. If this theory is correct, then our universe is the product of an uncountable number of previous cosmic generations, each one shaping the next, slowly fine-tuning the conditions that make reality possible. This would mean that the fundamental constants of nature, the precise values that determine the strength of gravity, electromagnetism, and nuclear forces, are not random. Instead, they could be the result of a cosmic evolutionary process that has unfolded across countless previous universes. But if universes evolve, does that mean there was ever an original universe? Or have there always been infinite past cycles with no true beginning? This question brings us to one of the most mind-bending possibilities of all, the idea that time itself is an illusion. The laws of physics suggest that time is not an absolute, independent force. Einstein's theory of relativity tells us that time is woven together with space into a single entity, space-time. It bends, stretches, and even stops under extreme conditions. Inside black holes, for example, time slows down to the point where it essentially ceases to exist. If time is just another dimension, one that can be bent and reshaped, then what we perceive as a beginning or an end may simply be a matter of perspective. Some theories suggest that the flow of time is an emergent property, meaning that, at the most fundamental level, there is no past or future, only an interconnected web of events. This idea is supported by loop quantum gravity, a theory that attempts to unify quantum mechanics and general relativity. In this view, space and time emerge from deeper discrete structures, much like pixels on a screen. If time itself emerges from these deeper structures, then the notion of a beginning to time might be meaningless. This brings us to the ultimate question. If time is an illusion and the universe is part of an infinite cycle, then what does that mean for us? Are we just temporary patterns in an endless cosmic flow? If the universe repeats itself endlessly, does that mean we have lived this life before and will live it again countless times? Some interpretations of physics suggest that the multiverse could contain copies of ourselves, living slightly different versions of our lives. But if time loops endlessly, then our own personal experiences could be part of a grander pattern that plays out across eternity. At this point, the boundary between physics and philosophy begins to blur. We are confronted with questions that stretch beyond science, questions about existence, purpose, and the nature of reality itself. If the Big Bang wasn't the beginning, then what is the ultimate fate of the cosmos? Will the cycles of expansion and contraction continue forever? Or is there some hidden mechanism that will one day bring the cycles to an end? The search for answers continues. Scientists are looking for new ways to probe the earliest moments of the universe, hoping to catch glimpses of what came before. If we can uncover the truth about the origin of our universe, we may finally unlock the greatest secret of all, the secret of existence itself. But we're not done yet. There's still one final shocking possibility to consider, one that could rewrite our understanding of reality forever. What if the Big Bang wasn't just a cycle? What if it was a simulation? Could our universe be an artificial construct, created by an intelligence beyond anything we can comprehend? The final section will reveal the strangest and most mind-bending theories of all. If you thought things couldn't get weirder, just wait. Imagine this. Everything you've ever known, your memories, your thoughts, the vastness of the cosmos itself, could be nothing more than lines of code running on some unfathomable machine. A universe simulated by an advanced intelligence, existing for reasons we can barely begin to comprehend. It sounds like science fiction, but some of the greatest minds in physics and philosophy take this idea very seriously. Could the Big Bang itself have been the moment our reality was switched on? And if so, who or what was behind it? This brings us to the simulation hypothesis, a theory that suggests our universe is not the base level of reality, but rather a vast and complex simulation created by a higher intelligence. The idea isn't new. Ancient philosophers like Plato questioned whether our world was just a shadow of a deeper, more fundamental reality. But in recent years, physicists and computer scientists have revived the idea, arguing that, as our own technology advances, the ability to simulate entire universes is becoming increasingly possible. If we can imagine it, why couldn't it have already happened? In 2003, philosopher Nick Bostrom proposed a compelling argument. He suggested that if a civilization ever reached a level of technological advancement where it could simulate conscious beings, then it would likely create many such simulations, perhaps even billions or trillions. If that's true, then statistically, the number of simulated beings would vastly outnumber real ones. Meaning, the odds are that we are living inside one of those simulations rather than in the real world. But how could we ever prove such an extraordinary claim? Some scientists believe we might already be seeing the fingerprints of a simulated universe. The laws of physics appear to be governed by strict mathematical rules, almost as if they were written into a program. The speed of light, for example, could function as a kind of rendering limit, much like the maximum processing speed of a computer. Quantum mechanics presents even stranger clues. Particles don't exist in definite states until they are observed, much like pixels in a video game that are only generated when a player looks at them. Could this be evidence that reality is being computed in real time? And what about the Big Bang itself? If we are in a simulation, then the Big Bang could have been the moment when our universe was booted up. Before that point, there was nothing, no space, no time, just as a simulation doesn't exist before it is run. Some have even suggested that certain unexplained anomalies in cosmic background radiation might be glitches or signs of compression in the underlying code of reality. Could this mean our universe is running on some kind of cosmic supercomputer? But if that's true, then who or what created it? Some believe that an advanced alien civilization could be responsible, testing different versions of reality for unknown purposes. Others suggest that the creators could be post-human beings, possibly even descendants of our own species who have reached a level of godlike technological mastery. But there's another possibility, one that is even more unsettling. What if the beings who created our universe are not advanced at all? What if they are nothing more than curious programmers, teenagers in some other reality running a simulation just for fun? What if the entire history of human civilization, all of our struggles, triumphs, and deepest emotions are nothing more than an experiment in an alien science fair? It's a humbling, if not terrifying, thought. And then, there's the final question. What happens when the simulation ends? If our universe is being run like a program, could it one day be shut down? Would we even see it coming? Or would reality simply vanish in an instant, as if someone had pulled the plug? Some physicists have speculated that the ultimate fate of our universe, a sudden and unexplained end, could be the equivalent of an artificial system reaching its expiration date. But here's the strangest part. Even if we are living in a simulation, it doesn't necessarily change anything. After all, what's the difference between a universe that was programmed and one that emerged naturally? If the rules of physics remain the same, if our experiences feel real, then does it really matter if we are inside a simulation? Maybe the meaning of existence isn't about who created us, but what we do with the time we have. And perhaps, just perhaps, the universe isn't a simulation at all. Maybe the Big Bang wasn't a beginning nor a programmed event, but simply one chapter in an infinite, ever-unfolding reality. A cosmos that is eternal, without start or end, where every possible version of reality exists somewhere, somehow. If that's true, then the mystery of existence is even deeper than we ever imagined. In the end, whether the universe is a simulation, a cycle, or something beyond human comprehension, one thing is certain: the search for truth will never stop. And maybe that's what makes us special. No matter how vast, how strange, or how unknowable the cosmos is, we will always keep asking questions. We will always keep looking up, wondering what lies beyond the stars. And with that, we leave you with one final question. If the Big Bang wasn't the beginning, what do you think came before it? Let us know your thoughts in the comments below. And if you enjoyed this journey through the cosmos, don't forget to like and share this video. It helps us keep exploring the greatest mysteries of the universe together.